Hello, everyone. Welcome to our presentation. Thanks so much for joining us. In this short video, we want to see how we can use a shortcut method via triangle method with regard to determining the inequalities of straight lines, right? So that is under linear programming. Okay, so let's look at the questions. So we are saying write three inequalities that define the unshaded region R. So you can see we have got three lines here. So these three lines are defining the unshaded part. So we need to write inequalities for each and every line. All right, so what I'm going to do is to name these lines. So we can name this as our line number one. We can name this one as number two, so for reference, so that it's easier for you to follow. Then this one, we call it number three. Okay, so the first line is straightforward, right? Even if you are told in an exam that you're remaining with 20 seconds, you're able to write the inequality for that one, all right? So what do you do? So you look at the first inequality, or the first line, that is just passing through at only one axis, that is the y-axis. Okay, so I'm going to say, since it's passing through at y-axis only, I'll say y is equal to identify the intercept. At what point is this line meeting the y-axis? So you can see that this is 0. So going down here, that is negative. So it means this number is -2. So y is equal to 2. That is your equation, right? Now we need to determine the inequality or inequation. We look at the area that is not shaded. Okay, so you can see that the area that is not shaded, it is above -2. So any number above that is greater than that, right? And where it is shaded, it is below that. So we'll say y is greater than -2, right? But is above. But again, we're able to see that this is a solid line, a complete line. So we are going to attach a line down there, a bar there. So we have got y is greater or equal to -2. So that's your first inequality. You don't need to waste time. All right? So that's number one. So we look at the second inequality. Okay, the second inequality, um, which is this one. No. I think let me say the second inequality should be that one. It should be this line, this one. Okay. So to do that, there are a lot of methods, but we are going to say y is equal to mx plus c, where m is the gradient of that line, right? And c is y-intercept, the point at which the line is meeting the y-axis. Okay, so clearly you can see that for this line, the y-intercept is at 2, right? So this implies that c is equal to 2. Then we are just going to substitute into this equation. Right now, we need to get the gradient. So the gradient is defined by changing y to change in x. So what we are going to do ourselves is to look at the line that we are dealing with and try to create a triangle. So we can draw a line like from this point of intersection up to this one. So we have got this small triangle in green. I hope you're able to see it. Right? So there's that triangle that we've created. Okay. So what we need to do is to identify the length here for x, that is 1, and the length here for y, that is 2. So it means here we are going to have 2 divided by 1. All right? So that is our gradient, basically. Now, your answer, ignore the signs first. So your answer is 2. Now, we need to identify the sign that will attach to this number, whether it will be, sorry for that, uh, whether it will be +2 or -2. Right? Now, since the line is slant towards the right-hand side, so it will be positive. The one that is going to the left, it will be negative. So this one is maintained as the positive. Therefore, our equation will be y is equal to m is 2. Your x is maintained plus your y-intercept is 2. Okay? Now, we can check the inequality now by looking at the shading. So this will imply that since we have got a dotted line and at the point of intersection with y-intercept, the part that is not shaded is below here. So any number below 2 is less than. So it means we have y is less than -2x plus 2. This is your second inequality. Don't waste time. This is your first inequality. Then we can do the third inequality by using 3. So what are we saying? We are going to use the same approach, plus c. So now I'm going to get the gradient. So in this case, we are dealing with this line. So the triangle is already created. If you're able to see it, I'll use the green color. So we have got this. This is our triangle here. So this is the y. You can see that y here is 5. Okay. And this is x. So x is 2. So y divided by x. So we have got 5 divided by 2. That is our gradient. All right. But again, we must check the sign of this gradient. So you can see that the line is slant now towards the left-hand side. So the gradient here is negative. Okay. What is our y-intercept? At the point of contact here, you can see that c is 5. Therefore, we can write direct an inequality if we want. We look at the unshaded region. At the point of contact here, as you go above here, it is greater. Below that, 5 and below here, it is less, all right? So this implies that your inequality to be y is less or equal to -5 over 2x plus 5. This is your inequality. So you have got 3. So you're supposed to write the 3 here. That's y. So y, the first one is y is greater or equal to -2. Greater or equal to -2. And the other one is y less than -2x plus 2 plus 2. Then the last one is y is less than -5 over 2x plus 5, if I'm not mistaken. Yeah, less or equal to for this one. So basically, that is your solution. That is, you don't need to start using, say, y minus y1 is equal to m, x minus x1. Of course, this works out as well. Please, you can contact us. We also have holiday lessons, all right? Yeah, please contact us for all the levels, be it Form 1, be it Form 2, be it grade 10, be it grade 11, be it grade 12, including A levels. Okay, till next time. Bye-bye and God bless.